Hey everyone, today we're going to be talking about factoring polynomials, and there are a lot of different ways that we can use, or methods that we can use for factoring. Some of these methods are going to look familiar to you because we used them back last 6 weeks whenever we did factoring of quadratics, but then some of these are going to be brand new. So I'm going to briefly go over these, but then some of them we will talk about more as we get to them. The first one I want to talk to you about is GCF, greatest common factor, and we did this a lot last 6 weeks. Whenever we were factoring quadratics, we would always check this first. We would always see if there was a greatest common factor that we could take out in order to make our numbers as small as possible that we were looking at. So always check first. So an example of that, just to refresh your memory, if we have a 30x squared and a 5x, with our numbers, we see that the 5 is a factor of 30, so we could pull a 5 out. We also have x's in both terms, and the smallest exponent is the one that they're going to have in common. So I have an x to the first power here, so I can pull out an x. We say that we are going to take this 5x and divide each of the terms by the 5x and say what's left here. So that would be an example of pulling out a greatest common factor. A lot of times they were just numbers last 6 weeks, but this time they'll be numbers and variables, sometimes variables with exponents. The next three that we're going to talk about is difference of two squares, sum of two cubes, and difference of two cubes. So the way that you're going to know that one of those factoring methods will need to be used is if we have two terms in our polynomial. If we have two terms, we're going to be using one of these methods to factor if it's a factorable polynomial, and we'll get into that a little bit later. We talked about difference of two squares previously. Anytime that we have the b term missing here, when in an ax squared plus bx plus c type of equation, if we have a perfect square as our first term and a perfect square as our second term, and specifically subtraction between them, we can rewrite it in this form. We take the square root of those perfect squares and put that result, the a in the front, the b in the back. One of these factors gets a positive and the other one gets a negative. Sum of two cubes and difference of two cubes, I've broken those out a little more below, so I'm not going to spend time on them here. Grouping is new, and grouping is what we're going to use if we have a polynomial that has four terms. And in order to do that, this is the actual formula, but we're going to use a little bit easier method called a factor box. So we're going to use a factor box. Basically the same type of box that we'd use in our Xbox method for factoring quadratics. So it's going to look familiar to you whenever we get to that. And then finally our quadratic form. And we know that quadratics typically have three terms. And if we have three terms, then we're going to be looking for factors that we can put here. And we will use our Xbox method just like we did before to do that. I do want to point out one last thing before we leave this table, and that is this asterisk right here. It says difference of two squares. Notice that when we get to cubes, we have a sum and a difference of two cubes, but there's no such thing as factoring a sum of two squares. So if it's two squares, it has to be a difference, a negative sign. We can't have an a squared plus b squared. If we have that, it's just honestly not factorable.